Good evening, Daniel. How you doing? I'm going to start desktop sharing. Okay, are there any questions? Good evening, Mega. I've got, let's see, something on the team projects here. I don't know if this is matching your, Neil said his team project has been submitted. I'm going to check that. Looking where Neil is. Oh, he's the team 1. Yeah, he's done. He submitted it, so that's good. I would have told him I have question marks, meaning I think these students have dropped, but they haven't withdrawn. They're still in the class. So if you have them assign something, I don't think they're going to. Team 5 has been hit pretty hard. But you still have 1, 2, 3, 4, 5, 6 students. And that's kind of my update for the project. Do you have any questions, or where are you guys at? You should have had, by this time, I would guess, at least a rough draft. Okay, very good, Daniel. What group are you in? Team 3. Yeah, Team 3 doesn't seem to have any issues. Mega's in Team 3. Mega, how's everything coming? Quan just reached out. I'm not sure what we can do for him. He didn't email me, but we'll see. Yeah. I'm not sure what we're going to do about that. I'll just wait until I see an email. Daniel D., I saw your name somewhere. Right? This is you, Daniel? Okay. So I think everything's going well there. Good. Because it's due this Sunday. I built the final exam, and I thought we would start to go through. There's not going to be any more questions, well, any other questions, meaning anything but the final exam. Just start reviewing your questions, because when I reviewed them, I had to make changes in the question to make it sound clearer to me. Everybody got at least one of their questions on the test. Some got 2, and one person I think got 3 because they were the only ones submitting for that chapter. Any of work along with the project must be turned in by Sunday. I'm not going to accept anything after Sunday. It's just too hard for me because I'll be doing the grading of the projects, and that takes quite a while to read through them. And then any of the late turned in homeworks. So I'm not going to review after Sundays. Well, this would be Monday. Monday, I'm not going to review again any work that's been turned in. It's just not going to happen. Just in case, what you need to do is LinkedIn is kind of a nice tool to keep in touch with other class members. I'm not big into social media, and you might have saw that in my reply in the discussion. I replied to about 5 discussion items earlier today, and this was one of them about social media. I kind of wrote an essay in that. CC Confer will be answered on Thursday. I got another email from Maker Faire, and I thought I would share that with you. This was the email I got. We've added exciting features such as Industry, Career, and College Day on Friday. That sounds interesting. I'll post this on the so you can pull it off if you'd like that link for tickets. So I would definitely, if I'm interested in future computing things, go there. Okay, let's take a look at the final now. Unless there's any questions. If there's questions on something else, we can answer that. Otherwise, I thought we would review the questions and see how many we have reviewed that you guys submitted. Okay. No. No, I'm not going to post the corrected ones, Megan. Yeah, we'll discuss it tonight. That's why I wanted to do it with you guys. And I might give you some hints, too. Okay? Okay, so here we go. 44 questions that I've selected out of your questions, except I never got any questions for 12, 14, and 15. Therefore, you're not going to see these questions until the test. But you'll be able to see your questions. We're going to go through them. The optional has 7 questions, and they're all from me, worth 7 points, so a point each. So, and that's extra credit. So when you're there for the 2 hours, you only get 2 hours to do these tests. If you complete the test and you have time still, then do the extra credit ones. These are going to take you longer because they're really thoughtful questions. They're kind of my favorite questions. Like, remember in the optional for test 3 where you had to analyze a set of CPUs and I/O units on a graph and tell me where the like process A stopped, how many cycles, all of that. You remember that? Well, I have an example of that completely on the test, and the question I ask is, what is the true statement regarding what you see? Well, you're going to have to look at it and figure it out. So that's going to take time. So what I'm trying to tell you is do the 44, do them as correct as you can, and then jump on these, because this could take you half an hour to do 7 questions. Okay. There's approximately 3 questions per chapter. Okay. Some have 4, and some have 2 for that chapter. It depended on what I liked. Only do the optional after you finish the basic exam and still have time. Total time allowed for both is going to be 2 hours. So it's going to start at 6. You have to be on campus. It'll be in the ATC 203, the lab, and I think area D or C, one of those 2 areas that have computers. Mary Pape will be there. She hasn't confirmed yet, but she will. She's always done it for me these last 3 years. Okay, no book, 1-page handwritten notes, and this cannot contain the final questions. When you show your ID, you sign in, you're going to show your picture ID. When you check in with Mary, show your 1-page of notes. And I'm going to tell her that we shouldn't see any final exam questions written on it. That doesn't mean you can't put things about that area, like safe state, right? Understanding a safe state, that kind of thing. That's okay. You can't take pictures of the book and shrink it down and use a magnifying glass to look at your notes. Things like that. That's why it has to be handwritten. No makeups allowed for the final except those students on the Wednesday list. Now, let me check that, because I'm going to tell Mary who's going to be coming for the final. I thought I put it in there. I may have put it in the no, it's not here. Students taking finals on Wednesday. I've got Robin and Patricia are the 2 that'll be taking it Wednesday with Mary. That's who I have right now. If you need to do it on Wednesday, you need to email me by Monday, because Monday I'm going to send the email to Mary. Is that clear, guys? Did you understand all that? Okay. Good. It's in 203, Area D, from 6 to 8. There is a password, so you can't take the test somewhere else, right? You can't, like, oh wow, I know he's got a timer on it, but I can just get on and do it from home during that time. No, because only Mary's going to have the password. Okay? Okay. Well, you never know. And you can't use the internet, guys. And the other thing is, if you are paying attention to another screen, because it's on Canvas, right? The test is on Canvas. And you look over and you pick A because this person picked A or whatever. Those are going to be scrambled. Yeah, they're A, maybe, or B, exactly. That's why I picked none of these rather than none of the above, because that didn't make any sense if none of the above got to be the first one. So that's why I used none of these. And if people put that on their tests, I changed it. Okay, are you ready to go through the questions on a content basis? Okay. All right. What I'm going to do is I'm going to shrink the window. And you can't see the right side of this. Is that correct? Yeah, you can't see where my cursor is. All right. Because that's where I'm going to put the questions that I picked. Okay. All right. We'll start with Kang's. What is the function of an executable file? I didn't see anything weird about this. Did you guys? Okay. What's the following is not a disk operation? That looked straightforward. What pieces of data are needed to manage open files? This one threw me a little. Do you think that this is the correct answer? Yes. Thank you, Kang. Yeah, it took me a while to look at this. And the reason I got confused was I was looking at the name, the location, the size, and the protection. But more likely it would be if we're managing it. That's what we're doing. If it's in the operating system to manage, it's got to have file pointers to point to the file, not just the name, not just the location. Doesn't really even need the name. So yeah, I would agree that that's there. So it took me a while to talk myself through it. But thank you, Ken. Okay. I didn't make any changes to those questions. Okay. This is a fill the word in the blank. Hi, Karen. And it took me a while to figure out the first word, because I thought the first thing you did was seek. So there was a seek time or random access time. This must have come right out of something. Did this come right out of a book? Yeah, okay. Yeah, because sometimes she uses different words than I do. And you said positioning time. And I guess I'm really not sure. I think that's the whole thing. That's the whole process. And it consists of two parts, the seek, the rotational delay, and the latency. Yeah. Yeah, there's really three things that affect the disk's ability to get data. One is the seek, two is the rotational delay, and three is the transfer rate. Those are the three things that transfer off of that device. And I don't see transfer rate. That's what kind of threw me off. But these are fine. I didn't change this. This was a good problem. I like how you reversed it. That instead of going from the head moving from right to left, it's moving from left to right in this example. So if you were using scan, you would be going left and then coming back right. I didn't check these numbers. Did you? Are you sure these numbers are correct? No, we haven't hit one so far, Kang, that I changed. Yes, you did. Yes, you did. I didn't open it. I spent more of my time just, formatting it for my use and renumbering it and things like that. So no, I didn't check. That's why I asked you. I'm okay with these. Okay. Excellent. Good for you. I imagine that it's going to take time to do these. This one you had a chart. Yeah, right here. And the chart was of a disk. Its drive and all of that. Yep, it was. And I did load them in my CAN disk here. So I had to upload them, and then I had to add them to the test. So I shrunk them down in size a little bit. Were there any questions from anybody else on this? Were you able to see the diagram, guys? Okay. Where did I put that? Yeah, this is the picture. It was a good picture. And there's two because one's in a different format than this one. This is JPEG, and I don't know what this, I can't read that. But they're good. I'm glad you did that. Yes, I'm glad that you did that because Canvas is actually able to show both, but the JPEG is the better choice. Very good. I didn't have questions on this one either. Okay, chapter 7. Chapter 7. On the test, they're going to be in order from chapter 1 through chapter 15. Just made it easier for me. I have to find hers on this. Oh, yeah, I remember the issue with this one. Give me a second. I need to see the whole thing. This is 7 minutes. There it is. Okay, when is not an example of deadlocks that are not related. This was too confusing for me. I don't know about it. Ken, what do you mean? What number? Okay, I think I know what you're asking. Like, would I change 64 to 65 and then change these numbers here? Let me just say I might do that. That you actually have to think it through rather than say, oh, I remember that was this one here. Make sense? Yeah, whenever there's numbers like this, they're open to change. Let me just say I didn't use this question. How's that? It was just too confusing for me. And the other problem with this one is there's only 4 answers. So, and I don't like both A and B as an answer. So this question is on the test, but it's been changed. Yeah, even you guys commented on that. Okay, chapter 5. Chapter 5. And this is Cynthia. Yeah, chapter 5, I have 1, 2, 3, 4, 5. I have 5 questions for chapter 5 because they were pretty good. But let's look at Cynthia's. Any questions from you guys on this one? I changed it a little bit. Okay. So you know it must be on the test. Okay, let's see. The only issue I kind of have with this one is I thought we talked about first come, first serve as an algorithm. Do you recall that? No, okay. Are you there? Okay. Okay. Chapter. Chapter 5. I thought we did that. Algorithm. I don't think it was called that. Yeah, I'm just covering for a second the first come, first serve. Okay, so we did talk about it. Oh, I know why. I've got, these are all replacement algorithms, and this is a scheduling. I missed that. Yeah, you're right. It is the only CPU one. These others are for replacement, chapter 9, I think. So that's fine. I'm just reading through these. Yeah, that's false. That's false. This is the one that kind of threw me. Because basically everything is a thread. It schedules the thread for that process. So this could be true. So this would be changed a little bit. Okay? Any questions on that? It's chapter 11. Chapter 11. Okay. How many types of file are there in a computer system? When I talked about this to you guys, this is what I said, and I think it was iterated by the PowerPoint slide, that this is the way I think of them. And I think that's pretty true. Binary are programs, data files that are stored binary. And then there are a bunch of textual-based files. Like Unix uses a lot of files to set things up, and they're all text-based, so you can make easy changes. Matter of fact, like their drives are based on files. Almost everything is. Okay. That one's okay. The issue I had with this was none of these really went to why. Why disabling interrupts frequently can affect the system's clock. And he's got the system clock is updated, but that doesn't answer the question. You see what I mean? Mega, did you say no? You didn't see what I mean? Yeah, it was similar. But I don't think it was worded this way. I don't think this came right out of a homework question. I changed it. Okay? So this is definitely on the test, but I changed the wording so it made more sense to me. Okay? Okay. Consider a file system that uses inodes to represent file disk blocks. This was pretty cool. 8K blocks in size and pointer to a disk requires 4 bytes. This file system has 12 direct disk blocks. So that would be, what, 12 times 4. And then plus it has a single index, a double, and a triple indirect index block. What's the maximum size file can be stored in this system? And he's got 34 terabytes. I would change the numbers a little bit, okay, on this. But as a whole, this is not a bad question. Any questions? Okay, this is homework chapter 4. It's the quiz chapter. Quiz chapter 4. And it's Jada. This multi-threading model allows the operating system to create sufficient number of kernel threads. And he's got many too many. I don't, you know, the question that for sufficient, I think many to many is a good example of that. So yeah, I kind of like the question. Well, the challenge is in a multi-core system that puts pressure on programmers. Out of this, you know, the question, it seems to me that puts pressure on programmers, thread libraries, threading issues, and threading models. And this one, the one you marked true, dividing activities, balance, data splitting, data dependency. And this really, I guess, because it says testing and debugging, really would go to programming. So this one is a concern that puts pressures to understand how to do these things. But I guess this is more detailed. That's how I saw that. What do you guys think? Okay. Provides the programmers with API for managing and creating threads. Yeah, this is an okay question. You guys got to stop me if you disagree or not following. Oh, I missed that. Okay, process state. As a process executed, changes the state in its meaning. Process state. As a process executes, it changes that ready state. I changed this because it didn't strike me as talking about a process of a state transition. Okay, so I reworded this. What does a process include? Program counter, data section, stack, data section, time, shared system, program counter, batch system, stack, program counter. None of these. It actually could include some of this stuff, right? We talked about the program counter. I don't know about this time shared system. That would throw it out. It has a stack and data. It has program counter and data. So in my simple thinking, you know, all of those are possible. What do you guys think? Yeah. Okay. So this would be changed. What is, I guess it should be, what are the models of inter-process communication? Shared memory, speed up, message passing, both memory and message passing. I didn't like this question. I didn't use it. No, so we'll throw it out. Okay, now we've got more. And this is chapter 6. Which of the following conditions belongs to the circular wave protocol for deadlock prevention? He says each is that a tilde? I don't know what the guy, I just spotted that. Well, I know they all loaded correctly. Let's go through it. Which following conditions belongs to the circular wave protocol? Each process requests resource only when decreasing the number of enumeration. Each process gets resources up to n-1. I mean, he's got the idea. They talked about in the prevention, you had to count the resources. Each process requests resource only in increasing order of enumeration. Yeah, I think that came right out of the book. Only the process requests get resource. I guess it's okay. Let's look at this one. Which of the following is not a data structure involved in the banker's algorithm? Yeah, they have available and stated location. Yeah, they wouldn't have lock. And there's that at noon. Deadlock prevention. What must exist in order for the system to be in a safe state? This is not prevention, it's avoidance. I think the concept of safe state was you wanted to avoid going from an unsafe to a safe state. So it's not the prevention, it's avoidance. I don't even know what a safe claim edge is. I don't think I've seen that. So I guess this is it. A safe sequence of requests would be correct. But this is avoidance. Okay, number 1. And this is yield. Which is considered hardware? CPU, memory, monitor, user, mouse. Okay. I would reword this a little bit. It's pretty obvious to me that the user is not hardware. The one program running at all times on the computer is them. Okay, this would be reworded a little. Interrupt, application, system, bootstrap, kernel. You know, I think applications run on the computer. It's just that the wording doesn't quite fit. Because it could be applications, but all times. I'm just kind of confused by that. Is this clear to you guys that kernel answers this completely and not maybe an application? Something like, if I use it, the one program running most of the time is, I'd set that. Okay, a defense of the system against internal and external attacks is called security. What's the difference between security and protection? Anybody? Right. You know, what I'm thinking is, in terms of the operating system, it could be, when he's talking about the system, he could be talking about the networking as well. I'm just debating about this. When you think of protection, you think of file protection, you think of user access protection, and then when you think security, you think that you don't want anybody hacking into that thing. External attacks. So he's got both internal and external. So I would think then the security would fit that. Protection usually is within the system, internally. You think about file protections. You think about inside the computer. When you think of security, you're thinking both kind of inside and outside. So I would agree to his answer. That makes sense now that we've talked it through. Okay, chapter 9. A blank never swaps a page in memory unless that page is needed. Lazy swap. Yeah, that was the definition. Okay, I don't have an issue with that. Which of the following is not a page replacement algorithm? We talked about all of these. He made this up. I don't know what this meaning means. Daniel, was this your question? Yeah, it was. Ah, okay. I thought it meant something, but I couldn't decode it. That's good. I like the question. Oh, the pneuma. Oh, wasn't there a pneuma plant before in Santa Clara? A pneuma plant? New United Motors something. Fremont, right? It was in Fremont, and there's a new. I can't think of the name of the company. It's Tesla? Numi, that was it. Numi, thank you. You know, I walked through, I had a tour of the Numi plant when it was there. And have you guys ever been there? Yeah, it was bought by Tesla. They purchased part of it. I don't think they purchased the whole thing. Or maybe they're leasing it. I don't know. But have you guys walked through any of those big plants? That was really fascinating. Toyota had a whole philosophy, and they had their philosophy everywhere. It seemed like a nice company to work for. Okay, thrashing occurs when a process is not being added to the system. A process spends more time paging than executing. Yeah. We had a question of thrashing on the test, right? Test 2. Okay. Mega. Chapter 5. Chapter 5. Okay. Okay, which one of these is a non-preemptive scheduling? Non-preemptive scheduling. Switching from waiting to ready. Switching from running to ready. Switching from running to waiting. I disagreed on this one. Is Mega still on? We took this from a PowerPoint slide. So I thought it was this one. Here's let me explain why. I'm not sure on the slide. If it's running and it was switched to ready, it was preempted by something. It didn't voluntarily say, I don't need the CPU anymore. If it's switched to waiting, it's requesting service. So it fits the non-preemptive scheduling mode. So if this was on the slide, it was wrong. The correct answer is switching from running to ready. That would make it preemptive. Because remember, a non-preemptive system means that it runs until it requests service. Now what's possible, and that's what I'm kind of debating, is that there's this concept of give up the CPU. It would be called something like it would be like nice in Unix, to be nice about your priority, and basically say, okay, I can be interrupted, and then it could switch to ready. But the raw definition of non-preemptive means it executes until it either finishes, it aborts, or it requests service. It's waiting state. Okay? So, yeah, I used this, but I changed it. Yeah, we still have that up. Let's take a look at that. It was probably up further, wasn't it? Having an issue here with this. Okay. CPU positions from switches from running to loading, switches from running to loading, switches from running. Yeah, we talked about these states. 1, 4. Yeah, 1 and 4 is non-preemptive. I don't agree. I don't agree with this guy's, that's live. I would say 2 and 4. 2, 3, and 4. That's what I would say. Yeah, that's how I put it. Because 2 is preemptive. Yeah, I agree. Let me look at yours again. It's non-preemptive. Yeah, we did talk about that, but I didn't catch it enough to clarify it on that slide. Yeah, I said 2 is preemptive. This one here. And this would be an indication of non-preemptive, would it? Let me think. Yeah, you didn't select this. So yeah, it's running to waiting makes sense on non-preemptive. These other things aren't really a part of it. So the 2 to really examine are these 2. So you have it correct. Switching from running to switching from running to the waiting state is a non-preemptive action. For some reason, I thought the equal were here, but it's not. You have the equal here. So you're squared away. Okay? Now, I might change this wording a little bit. So be aware, Megan. I might say preemptive. No, you have the correct answer. The thing with in the PowerPoint slide, this is correct. If it goes to the wait state, but it could be either system. That doesn't really identify it. It could be non-preemptive or preemptive, because both types of process concepts would have that. Okay, would have that capability to go from running to waiting. This one definitely would be preemptive. And waiting to ready, either of those would have it. Terminate, either of those would have it. They would have those states in both operating system philosophies. The only one that really strikes me as switches from running to ready is preemptive. Non-preemptive would not do that. Okay? Did that answer the question? This is correct. Yeah, but like I said, when I went through it, I misread this thing, and I made changes, so examine it. It is on the test. And I need to correct something. I've got 2 words alike in this sentence. Let's look at the next one. Which one is a priority scheduling, where priority is the predicted next CPU burst, which might cause starvation? And shortest job first would, yeah, out of those. I agree. Okay, this one. Which one is an optimal CPU scheduling? Maximum utilization, minimum wait time, maximum response time, maximum throughput. Well, it would be max response time. That would make this thing false. Minimum utilization, minimum wait. That would make this false. That would make this false. Minimum response time, that's good. Minimum throughput, that would make this bad. Maximum utilization, maximum throughput, minimum turnaround, minimum response time. Yeah, that would certainly make that true. Very good. Nice, Megan. You did really well on this. Okay, and except for that first one where I got confused on it, I looked at the question. I mean, it is on the test, but I changed it, so pay attention when you see her question, because I changed it to make more sense to me, but you have it correct. It's just when I read it earlier tonight, when I was building the test. I misinterpreted this. Okay, chapter 10. Chapter 10. Holy cow. Dang. Alright, let's go through it. SCSI itself is a bus, up to 16 devices on one cable. And it's a fill in the blank. Probably got it from the book. I didn't have any issues with this. SCSI initiator, requests operations, and SCSI targets, perform the task, on the basis of storage area network, and arbitrary group, or storage area. Arbitrary. I guess it's okay. I find these a lot more difficult to answer. Oh, this is kind of cool. Suppose that a disk drive has 5,000, remember 0 to 400 MB. Drive is currently seeking 143 and the previous was at 125. The queued pending request FIFO order is 1 head, which is the minimum distance. Which of these out there? Did anybody check this? Okay, I'm moving on. Okay, whenever a process needs I/O to or from the disk, it issues a system call to the operating system. Request specifies several pieces of information except whether this operation is input or output, method of functionality, what the disk address, well, you sure need that, what the memory address, you need that, what the number of sectors, you need that, what the disk scheduling algorithm is. No, we don't really care about that. So yeah, this is correct. Okay? That's good. Those were good too. Chapter 2, Patricia. Okay. Blank allow the user level process to request service of the operating system call. Yeah, I would agree. I don't see any problem with that. Remember, if you have an issue, raise it in the chat window, because I'm really going through these pretty fast. Which one of these is not a type of system call? Process control, file manipulation device, information, application. Oh, I guess that what she's doing is the API actually uses inside there uses a system call. So the system call then would go to process control, file management, device information. So I would agree with this as well. I think it's pretty well worded. Okay. The blank reads commands from the user or from a file command and executes them, usually by turning into one or more system calls. Definitely, I would say the command interpreter out of all of this stuff is correct. Good question. Is this helpful to you guys? Reviewing it this way? Okay. Chapter 3, James. Which of the following statements does not represent a short-term schedule? Selects from the process that already executes and allocates a CPU to minute. Yeah, so that is what it does. So he's looking for what it's not. The scheduler is invoked very frequently. Oh yeah, that's true. It controls the degree of multi-programming. No, the master scheduler does that. So this is correct. Let's see if the others make sense. The scheduler must be fast. Yeah. And none of these are correct. Well, that's not true. One of them is. Okay. It's a good question. Process control block contains the following information, except, boy, he likes a lot of exceptions. It has the process state, it has the program counter, memory management information. I'd imagine he means a pointer to memory. Sockets, CPU registers are there. Sockets, what is socket in the PCB? I don't think so. A socket is just, it would be considered a data drive concept. So I don't think a socket is in the process control block. They might have pointers to it, to this, but I don't believe they would have the actual socket information inside the process control. So out of the three, the one that I question is this memory management information. I would have made it more simple, a pointer to the memory. I don't think it had the actual memory management information inside the PCB. Okay. Which of the following describes remote procedure calls? Contour allowing two processes to communicate. Yeah, because this remote means it's coming from another machine. So I'm assuming that this one would be on the same machine. Abstracts procedure calls between process and network. Yeah, it does that. Let's see. I mean, that's what he's got as the correct answer: infinite communication. Why? This is kind of tough too, because aren't those endpoints? Communication requires a pair of these items. Well, I can imagine it will require two activities: the requester and the machine supplying the request. So in other words, I didn't use this question because it was a little more confusing than I could understand. All right, what do we got next, Jesse? Oh, about deadlock. What is not one of the four conditions required simultaneously? Okay. Well, circular weight's one, no preemption's one, mutual exclusion is one, holding weight is one, cycling resource allocation graph, I'm not sure you would apply that to this. So, it's a good question. What is the runtime complexity of detecting cycles in a graph? Content complexity of detecting statements n squared. I think that was in the book. Do you recall that in the book? You want me to scroll down or scroll up? I said I didn't understand this one, so I didn't click it. I believe this came out of the book. So I didn't change any of those. Okay, what is required information for DevOps avoidance algorithm? So the avoidance was the safe state stuff. Minimum number of resources of each type of each process. No, that would not be right. Maximum number of process of resources of each type that process needs. That would be correct when you marked it correct. Minimum number of CPU units that each process needs. That would be kind of strange. We never talked about that, so that's wrong. Same thing about this maximum number of CPU units each process needs. They would not have that, and none of these. So this makes sense to me. Did I answer your question, Kang? Kang, do you hear me? Oh, he might have stepped away. Oh, he got kicked out or something. He's not there. Okay. Chapter 1. Okay. Which is not a component of a computer system. Hardware, operating system, application, program, users, the internet. I would agree, but usually you have the hardware associated with this. But I guess he means maybe being a hub on the internet. Welcome back, Kang. Yeah, I answered your question, and then I asked if you got it. Did you get the answer? Yeah, okay. You were asking if I'd scrolled back, and I was on this question here, and I said I did not include this in the test. So that's the answer I think you're looking for, and that's what I asked. Okay? All right, very good. Okay, the next one, I'm going to move this over a little bit. Okay, the next one is Albert's, which is not, I went through that one with you guys. Okay, let's look at the next one. Privilege refers to processes that stay in main memory, hardware manufacturing users with wide and movement access, process with higher priority, instructions only executable in kernel mode. Yeah, I mean these others, no, doesn't make sense, but yeah, this makes sense. The top level of a storage device hierarchy is registers out of all this. That's correct. Very good. Any questions on these? Okay, let's go chapter 9. In FIFO page replacement algorithm, the page must be replaced. Newest page is chosen, and oldest page is chosen. Correct. Random page most frequently used in many of these pages. Yeah, this looks good. A lot of these anomaly states that more frames will cause more page count. Yeah, but it has to do with FIFO, that particular algorithm. So it's fine, except should mention that it goes with that algorithm. Okay. Which algorithm chooses the page that has not been used for the longest period of time whenever a page is required to be replaced? So that would be principle of optimality. First out, least frequently, most recently, hot policy. None of these. That's correct. Very good. Okay, let me illustrate something to you guys on how I might change a question. Like on this one, the oldest page is chosen. I could put something like the not used recently, that we talked about, the not used recently algorithm. And then in that case, none of these mentioned would be true. I could do that. So when you are reading the questions and you look for something like what you think it should be, it might be completely false, and then it would be none of these mentioned. That's one way I could change a question. Okay. Another way I could change a question is remove none of these and pick the principle of optimality, and that would be the correct answer. Do you see how I could change these? And that's what I would do, so that's why I'm telling you that. Okay, next one was, did we review that? Did we review this one? Yeah. Okay, Jonathan, chapter 8. Total memory space exists to satisfy requests, but is not contiguous. It's called, external fragmentation. Good. So what could happen on a question like this is I could replace this with a incorrect answer and then make the none of these correct. Or reword the question a little bit. That could happen. Chapter 8. What allocates the smallest hole that is big enough if it's ordered by size. Best fit. Yeah. Okay. Okay, Jonathan, what is combined with the base address to define the physical address? Page offset, page number, entities, page table length, translation, etc. Yeah, it would be the offset within the page. Good. That was good. Those are good questions. Okay. Chapter 8. Shooting. And we have a diagram here. That's what the question is. So, process 1, I guess, let me think about this. Process 1 has data 1. So where is 1 in these codes? It looks like in process 1. Yeah, so I guess process 1 has data 1, and it does. Process 2 has data 2. Process 2, where's the 2? Yeah, it looks like it does. And 7. I don't know if I'm reading this right. It might be page number. Yeah, I think I'm reading this wrong. Since these are both 2s, we're okay. But I think it's page 7 is owned by process 3. Page 2 is owned by process 2. Is that 2 or 3? That's so tiny. No, it's process 3. No, that's why. This is 2. This is 3. So 1, 2, 3. So when I said that process or page 2 is owned in data 1, it's not in there. So after you go through it, you find out that, yeah, that this is the true one right here. That 7 is owned by 2. 2 is owned by 3. And 1 is owned by 1. So yeah, that's correct. It's a very interesting question. Let's look at any questions on that one. You guys, you okay? Welcome, Albert. I did review your questions. I don't know if you were here when I did. Okay, Shuin. Number 2, or second question. Assume the user has can't read it. Okay. Stuck images. I'm trying to keep this window open so I can see your comments. Assume that the user processes 100 meg in size and backup data has a transfer rate of 50 per second. And it takes 4 seconds to do whatever she said it was. So it was good. And then this one was interesting as well. Consider the following segment table. So these are the segment numbers. This is the starting address. That's the length of the segment. So the one that you said is invalid would be this one, 500. So you go to 2, it starts at 90, and it's more than 500, so it's a definite invalid address. Okay, the rest are all valid. You go to 0, start it there, and it goes 600, and you're only going 430 at the 600. 1 starts at 2300, and it only has 14, but you're only going 10 bytes in. We went through that one. 3, 13, 27 for 580, and you're going 400 of it. So all of those are valid addresses except 2, so this was done well. The only thing that I see a problem on this one is there's only 4 of them. So this is how I could change this problem. I make this correct, so it would be maybe 90, right? 90, and put none of these, and that would be the correct one. I could do something like that on a problem like this. It's easy to do. So be aware of these minute changes I'm telling you about. Okay, chapter 5. We have quite a bit of 5s. And they're all good. By the way, these are all good questions, you guys. You did a real good job. Better than I would do if I had to sit down and write tons of these questions. Which of the following is not a multi-level feedback queue rule? All processes entering the ready list start at level 0 and preempt any lower level queues. That's true. A preemptive process is placed at the beginning of the level it is at with the remaining quantum as its new quantum size. A preemptive process. Yeah, oh yeah, right. A preemptive. That's right. All levels quantum size increase as the number of levels increase, correct? Any process that times out at a level we place first come first serve in the next lower level. We kind of talked about this. Any process that times out at a level will be placed first come, first serve in the next level. Yeah, that's correct. That's correct. I was thinking of something. At the lowest level, if a process times out, we override the algorithm and let it finish. No, we don't. We go typically round robin in that lower level queue. So she's got it right. It's a very good question. Okay. Next one that she has is, which of the following CPU algorithms is not possible to determine? Shortest job first, first come, first serve, multi-queue, round robin, priority. It's not possible to determine. Yeah, you can't use it in your algorithm because we don't know how long that job is really going to run for. We don't know. So that looks correct to me too. The first objective in maximizing the usage of the CPU during scheduling is knowing the type of program running. The type of program running. Now let me look at the other answers. How long the task will take to complete. Which CPU algorithm we're running. The average. The type of program running. How large the task is. What do you guys think of this question? Do you agree with the answer? That's what I thought. And that may be what this is meaning. Is it CPU? Is it I/O bound? I mean, that's what it could mean. Well, I didn't use it, so let's skip it. Let's look at 6. Xingling 6 was the only person that put in questions for Chapter 6. So let's take a look at them. Which one of the following is a synchronization tool? Thread, pipe, socket, semaphore. Yeah, out of these, I would say semaphore would be the synchronization tool. Okay. A critical section is a program segment which should run in a certain specific amount of time. No, that's not true. Which avoids deadlock. Well, you'd like to, but yeah. Where shared resources are accessed. And that's typically where you would use it. Which has security enforced by file access management. I'm not sure how that applies. Which only accessed by Linn user. I don't see how that applies. So yeah, I would agree with this. Okay, last one. If a process is executing in its critical section, then no other processes can be executed. Excuse me, I'm yawning. You got 15 minutes, but we're almost done. If a process is executing in its critical section, then no other process can be executed in the critical section. This condition is called mutual exclusion. Looks good to me. How I might change this problem is make something up here and change this to none of these. Okay? Remember, I can do those things. Chapter 4. And this is what Chapter 4. Multi-threaded programs introduce all the following challenges to programmers except for signal handling. Yeah, you have to handle that. Thread cancellation. Yep. I'm not sure carriage return would be there. Thread local storage. Yep. And deadlock. Yeah, those are challenges. I don't think carriage return is a challenge. Not to a programmer. Okay. The following are all benefits of multi-threaded programming except for, well, responsiveness is a benefit, resource sharing is a benefit, economy is a benefit, scalability would be a benefit, accessibility. She has that as the right one, but I would agree with her. That doesn't. That's not a stated benefit. I mean, you're more accessible to that program because you're using multi-threading. No, I don't think so. So I agree with that. Let's see what else she's got. What multi-threading model maps each user thread to a corresponding kernel thread? Well, one-to-one. That's pretty obvious. Any questions on that one? Because I think we're done. Yeah, it's possible. Are there any of these that you wanted to look at again? Okay, then. I'm going to just make the window larger again. Okay. Let's go back to the agenda, because I think we're pretty much done this evening, unless you have questions. Okay, we talked about all of this stuff. We went through all your questions. I told you how I could change them, and I told you that we don't have anybody turning in 12, 14, 15, which I couldn't review with you. But I got those questions done. We have a total of 44 questions. And each chapter has a minimum of 2 questions. And a maximum, I think, of that one chapter, like chapter 5, I think I had 5 or 6 questions on chapter 5. I talked about the handwritten notes. They can't contain the final question. You can't access the internet. You just have Canvas. Mary will have the password to get the test for you. And then that's about it. Any questions? That'll take about 10 minutes. The lab is open during the day, so you'll have plenty of time. Oh, you mean it might be locked? Oh, yeah, remotely? I don't know. I don't think you can access them remotely. But you can get in this week sometime and create your accounts if you're worried about that. That's right, Megan. Yes, and I'll show who wrote the question. Exactly, it'll be very close to what we just saw in that format, except it'll be on Canvas. And you won't see numbers A, B, C, D, E. What you'll see is a little circle that you pick one. Same as what you did with the multiple choice questions on tests 1, 2, and 3. It'll look exactly like that. And I think I set it up so that you get all 44 questions on one screen. So you just scroll down. You don't have to page. I don't believe, yeah. When I took it, I scrolled down. I didn't have to go to another page. Any other questions? These are great questions. One blank sheet of paper, sure. I'll tell Mary that you could have one blank sheet of paper. And I'll tell her you could use the calculator on the computer. You don't have to email me. I have the wait list here. Let me just add you. Yeah, you have to give me your whole name, Albert. Thank you. And your email address? Thank you. The only reason I have that is I'm going to give her that in case something comes up. I don't think she'll email you, but you never know. I'm going to check that I put that correctly. 2272. 2272. Yeah, I'm going to mail her this information on Monday. So you got it. Any other questions? You saved your email with an extra 2. Uh-oh. You saw that, huh? Oh, I did. No, then that wouldn't work. Glad you spotted that. Thank you. Well, guys, I guess this is, we'll call an evening. On Thursday evening, it's going to be very short. Since I've gone over this, what I'll do on Thursday is just review. I'm not going to review the tests in detail unless you have a specific question on any of them. So it's going to be a very short session. You might want to discuss something like that's in operating systems that you're interested in. Maybe we can delve into something. Other than that, I don't have any plans. Where will you see the points? Yeah, I'm not happy with Canvas when it comes to discussions because it just doesn't do a good job. So I have to actually go through the whole discussions and add them up. But I do have something in the portal for that. I think it's right up in the grade area somewhere. Yeah, it's here. So this is where I enter grades. It's called 2 posts and 2 replies to posts worth 40 points. So what I'll end up doing is I'll go through the discussions because I can see them here. These I'm not going to count. Those are the final exam. But all of these discussions, except the form, the team forums ones. So like this one, there's one, and it has 2 replies. So I have to chase down and see who replied. Like there's no reporting of this. And Catalyst did a much better job of reporting these things. So I'm going to have to open up all of these and find out who replied. And I'll add them all up. And if you get 4, you get 40 points. You have 3, you get 30 points. You have 2, you get 20 points. If you have 1, you get 10 points. If you don't have any, you get 0 points on this grade item that I showed you in called completed post. And that'll show in the grades. And they probably won't be in there until Monday. But I'm going to try and do it Monday. Because Monday, remember, Sunday is the last day I'm going to accept any work, including these posts. So I'm going to add them up Monday and put in the score. And whatever's posted at that time is what I count. What else is there on the grading side? Somebody asked me about this test makeup stuff. It's extra credit, and you have to send me an email if you had less than 32 points on any of the tests. Send me an email, and then I'll tell you what chapter, how many questions at the back of the book you should answer to get those points. One student was already, let's see, I've only had one student, and I gave them their points to get them to 32. And then I had another student today ask me if they could do it if they have a 32 on the test, and I said no, you can't. Because 32 is the cutoff for a C on these tests. And I guaranteed to you guys, if you did the work and you did the makeup work, you would get a C in the class at a minimum. Most of you are getting much more than a C, and the reason is because you're doing the extra credit work. Like you turned in 12 and 13. See, where is that? Here they are. You've turned in 14 and 15, and that's extra. So if you did both of those and you did it completely, you would have gotten 16 extra credit points. So, you know, I'm expecting quite a few A's. All right, I'm going to call it an evening. I'll be on Thursday, and we'll finish up the course Thursday evening, and then you have next Tuesday and next Tuesday and Wednesday to do the final. Thank you all for participating tonight. You can, the class evaluation opens on Monday and it closes on Wednesday, and it's worth 10 extra credit points. So yes, you can do that. That's available for everybody. You're welcome. Thank you.